Did you guys like that workout earlier? I hope so. But guys, the real work is done here and here, meaning understanding what we're trying to do and what you eat. Remember I said that the immune system is mysterious. We know certain things about it, and over the course of these 40 days, I'm trying to give you the very best of what I know. It matters how you begin your day in the morning. I will do a whole seminar just on the benefits of breathing that we're doing, not theoretically, but scientifically. What we know that breathing does for your heart, for your lungs, for your parasympathetic nervous system, which is your rest and digest system, which, guys, if you don't think that stress has anything to do with your immune system, you're wrong. Now more than ever, we need to manage stress, because stress puts a tremendous amount of pressure on certain organs, which we'll talk about another time. Moving right, breathing right, getting out into the fresh air and into the sunlight. I'm a poet and I didn't even know it. It all matters. But guys, what you put in your mouth matters almost most importantly. And if we understand how things work in the body, you're going to be able to take this with you for the rest of your life. You don't have to, this 40-day challenge becomes something that you can share with your children. Imagine that. Imagine teaching your children how to have amazing immune systems. Because guys, just like insulin, hear me out, just like insulin and many other things in the body affect different bodies differently. Meaning, this hormone in some people is the cause of downstream effects in their body that will and have led to serious illnesses, meaning heart disease, which was high blood pressure before that, which was high blood sugar before that, which was something going on with their digestive system before that, or with that. It can go on and on here, guys, which is mitochondrial function along with that. All these things we've been talking about, but I just want you to hear me out with this hormone right here. It's a hormone that your body makes and it's supposed to make, and yet its misappropriation leads to serious disease. Now, what does this have to do with this COVID-19? Notice how this virus is affecting different people. Lots of people are asymptomatic. Some people are getting a little fever, a little cough. Some people are winding up in the hospitals, and some people are dying. Same virus, different bodies, different effects. What's the common theme? Well, there are certain things that we know for sure. If you don't believe me how hormones matter, just take a look at the amount of women dying compared to the amount of men. There are way more men dying than women. And almost certainly, like we talked about in another video, estrogen seems to be protective here. Guess what estrogen is? It's a hormone. It's a hormone, guys. Now, does that mean men, we should start trying to increase our estrogen? No. What I am saying is that there are hormones that matter in the whole entire pool of your immune system. It's not just your age. It's not just your gender. It has to do with understanding the whole picture. So if we start our morning breathing correctly, making sure our parasympathetic nervous system is online, our rest and digest system, getting all the benefits from that breathing work, which we talked about nitric oxide. We could talk further about other things that are happening there in another seminar. The red light therapy, which I explained to you guys a little bit, but I told you about Dr. Hamblin from Harvard University. If you want to look into near infrared and far infrared and why you should probably be shining that in your mouth, on your throat, and on your lungs, I suggest you do it every morning, guys, for 30 minutes and follow along. Do your research. Then move your body. Get out in the sunlight. Do those things. But guys, understand that eating matters most. So let's get into this a little bit. Insulin. Let me start from the bottom. I'm going to keep this really simple. I just want you to get an appreciation here for how important this is. Many of you are on things like potassium channel blockers, calcium channel blockers, or metformin. Please understand that insulin has to do with all of this, how potassium leaves your cells or comes into your cells. similar to calcium, similar to glucose. And this is just I'm just giving you a short demonstration here that what insulin is doing really matters to some of the medications you're on and the state of the cell, meaning how it's charged, and also the health of the cell. So if we use, for example, just glucose, I'm just going to do this very quickly. When there's a whole bunch of circulating glucose in the blood, now, mind you that high blood glucose is a symptom of insulin resistance. It's a symptom. So if you take your blood sugar in the morning and you notice that it's constantly 105, 110, 115 or higher, and it stays that way, anything over 115 consistently is likely type 2 diabetes, and you're likely insulin resistant. So you keep that up, and the consequences of what this insulin is supposed to be doing, this very important hormone, is going to affect a whole bunch of things in how you metabolize certain macronutrients and how your body stores fat. So when there's a whole bunch of glucose outside of the cell, one of the things that insulin does is it basically helps to bring glucose into the cells. The problem is what happens if this cell already has plenty of energy? It's already full. Okay? So you have insulin saying, hey, let's go, get in there. And the glucose, or the cells go, no, we're good, we're full. Well, you can imagine that over time, that signaling of insulin starts to dampen. Okay, it starts to dampen. Now, we want insulin to do its job. And one way for us to really make sure that insulin does a bad job is to eat way too much sugar and just way too much food in general, which we'll talk about in a second. But please understand that this whole picture here has a lot to do with how insulin functions. Potassium, calcium, and glucose in the cells. And then there's magnesium, there's a whole bunch of zinc, there's a whole bunch of other things that go on in the cells and other mechanisms here, electrolytes, sodium, but I'm just giving you an example. Now, if we look at, what is it that signals insulin? We know for sure that if you consume a whole bunch of, for example, high fructose corn syrup, we know that insulin's going to go way up. And if you have high protein, it's going to be way less. If you have just high fat, it's going to be even less than that. You're going to notice glucose sort of spikes. You can see me over here, right? If you have just glucose, it'll spike insulin very quickly like that. If you have protein, it'll kind of spike like this and then kind of go down. Where fat will kind of come up a little bit higher, but then get lower faster. Okay, this is in the context of other macronutrients as well, meaning that when this is tested, we're talking about a diet that's mostly fat, some protein, some carbs, or mostly carbs, some protein, some fat. You get the idea. But the bottom line is, my takeaway here is that I want you to understand that if you have something like high fructose corn syrup, really like a soda, you're going to spike insulin hard. Now there's another model that says, yeah, but we know beyond the shadow of a doubt that it really has to do with ATP and ADP in the pancreatic beta cell. Now ATP, what is it? Adenosine triphosphate. And if you don't know this stuff, go back, listen to the seminar that we did on mitochondria. But I'm not going to make this super hard. I just want you to appreciate what's happening here. So there's one thing that we know that really spikes insulin, and is a lot of sugar. There's another thing that we know that has to do with the pancreatic beta cell and the ratio of ATP to ADP, meaning that when the natural balance goes way more toward ATP than ADP, which is adenosine diphosphate, so tri and di, 3 and 2, when there's way too much, we know that that signals insulin. So on the one hand, we know that there's a signaling at the cellular level, and there's this signaling at the level of the diet. So there's a combination of these two things that are going on. Okay, and if you go back and hear what was said about mitochondrial dysfunction, about that electron transport chain, right? There's a backup. Okay, what does mitochondria do? It creates ATP. It's one of the things that it does. It creates ATP. And what did we say? We said that if you want to have dysfunctional mitochondria, eat way too much food. You're going to get a backup here. That backup leads to oxidative stress. There's just way too much food. And you start to have this leakage in this electron transport chain. We talked a little bit about CoQ10 and ubiquinol here. And those of you that are on statins definitely need to be taking CoQ10, definitely need to be taking ubiquinol, because we know for a fact that in this electron transport chain, I don't remember if it's complex 3 or 4, but statins hinder the ability for that particular channel to make CoQ10. So, way too much food, too much ATP. Similarly here, way too much ATP than ADP. We know that that signals the pancreatic beta cell to create more insulin. We know that way too much sugar signals too much insulin. It's a combination of these two things. But then, let's take a close look at our digestive system, which I went into a little bit. So, up here, these are your lungs. And down here, that's your diaphragm. Here's your liver. Here's your stomach. Here's your pancreas. Here's your duodenum. We talked about these things. So, how is it that the liver gets fatty? How is it that the pancreas can get fatty and cause the problems that we talked about in the digestive seminar? Well, it has to do with carbs, proteins, fats, how much food we're eating. So let's take a look at carbs first. We know that if the sugar is really high, we know that we're going to signal insulin a lot. Similar, we know if we eat way too much food, we're going to signal the pancreatic beta cells to create a lot of insulin. Okay, it's a combination of these two things. Now, if we keep doing this over time, what happens? Well, there's too much energy, guys, and eventually we store fat. And what happens downstream now is we have what's called fatty acid spillover. So now, when we have fatty acid spillover, fat, okay, adipose tissue, starts getting stored also into organs, which includes your liver and your pancreas and other organs, okay, which surround your heart. And guys, listen, if there's one thing that we know that really maps on to heart disease, it's a high amount of visceral fat. And what I'm telling you is that visceral fat, meaning that organ fat, is a downstream effect of insulin not being able to do its job. Okay, how did that happen? Because there is so much glucose in the blood. The body wants to preferentially use glucose. As soon as you eat carbs, it goes right to the liver, and your liver breaks it down and preferentially uses it. Okay, your whole body preferentially uses glucose. Right? On the other hand, fat actually gets broken down, and it's actually your heart that preferentially uses fat first. And then it goes to adipose tissue, and if there's fatty acid spillover, can easily go into the pancreas and you have now a fatty pancreas along with fatty liver. Okay? So when we look at carbs, proteins, and fats, you may say, well, what's really the secret here? Well, let me give you the secret. When it comes to carbs, okay, let's make it real simple. Keep sugar as low as possible. Keep your carbs high in fiber. I said this yesterday. Depending on your genetics, this is why I do 23andMe stuff with people. Depending on your genetics, the amount of carbs you can handle, or the amount of protein you can handle, or the amount of certain fats that you can handle matter. But this also, if you can handle fermented foods, that doesn't mean have fermented food all of the time. It means maybe have a little bit of fermented food at each meal, meaning you could have a little bit of kimchi, a little bit of sauerkraut, you could have a little bit of vinegar. We know that helps dampen the insulin response. Again, if you have histamine issues, this is something that you're going to have to be mindful of, and go back and listen to my other videos where I talk about histamine. So for carbs, we want to make sure we're high fiber, vary those fruits and vegetables, etc. Keep refined carbs low. Anything in a box, can, package. Eat some fermented foods with every meal is ideal, or once a day. You're also going to get a lot of great nutrients in fermented foods like vitamin K2, and people that have digestion issues with certain types of veggies, fermenting them can be very helpful because it helps break those veggies down. Protein. Again, when we go back to this model, we know that fats and proteins are have very low signaling of insulin. Okay, that's good. We don't want to be skyrocketing insulin all of the time. Is there a time to do it? Yes, actually there is. When's the best time to do it? Just after you have a really, really hard workout, because insulin happens to be highly anabolic. Okay, so if you just did a really hard workout, that's the time to have your carbs and even some simple sugars in moderation, meaning about 15 to 20 grams is more than enough. I prefer to get my carbs post-workout from berries, blackberries, raspberries, blueberries, etc. And I mix that in with some fibers and a little bit of protein. The point here, guys, is that these macronutrients really matter where you're getting them from. Your protein you want to get from varied sources. You want to get some from plants, some from fish, some from animal, some maybe from organ meat. But you don't need a whole bunch of animal protein. You don't need a whole bunch of organ meat. Okay? So, depending on who you are and what you're doing, maybe have a serving of organ meat once a week, a serving of animal meat once a week, or if you don't eat organ meat, maybe 1 or 2 servings, meaning 4 to 6 ounces of red meat is good for most people, and fish a couple of times a week. And again, you want to vary that fish. Fish has all different types of amino acids. Protein is made up of amino acids. So some fish are going to be very, very high in certain amino acids. Like taurine is a very, very important amino acid for things like the health of your stomach. I mean, a whole bunch of things. But for example, scallops are super, super high in taurine. And fish in general have a lot of taurine. Just giving you an example that different amino acids are in each of these forms of protein, including plants. So you want to get a full spectrum of those amino acids. What you want to make sure is that you try to eat very lean meats here. Try to eat lean animal proteins, as lean as you can. The key here, guys, is if you eat way too much non-organic red meat along with your high sugar, low fiber, non-fermented, way too much abundant calories along with the alcohol, that is what leads to heart disease. This is starting to sound like the average American diet, along with the shitty forms of fat that they eat. Good forms of fat are going to be your nuts, your seeds. Okay, again, fat has a very, very, very slow, gradual effect on insulin. It's beautiful. So, but again, if you are already in a state where you have fatty acid spillover, meaning basically have metabolic syndrome, which we talked about, you are 30, 40, 50 pounds overweight or more, you have the high blood pressure, you have the high blood glucose, you have the organ dysfunctions, you got some, markers for heart disease, you got all this stuff going on. Here's the deal. If you eat a high fat diet and too many calories, okay, it is probably not your best approach, guys. At the end of the day, you need to eat less calories, meaning that once you metabolize your carbs, proteins, and fats, okay, it takes a lot more effort to metabolize protein than, for example, sugar. It takes a lot more calories to metabolize fiber as opposed to sugar. You get the idea? So where you get your food from matters in terms of your metabolism. So you can eat way more fiber, way more protein, way more nuts and seeds, and get away with it because it takes way more energy to metabolize that than sugar. So if you were to eat 5,000 calories, let's just say, of fibrous fermented foods with a mix of plant, fish, and animal proteins and some nuts and some seeds, and I'll go into more fats in a minute, certain oils. You eat 5,000 calories of that. By the time you're done processing it all, it's probably only going to be about 3,000, maybe 3,500 calories. You do that with sugar, almost all of it is going to get right through you, and most of it is going to go right to the liver. And we already talked about this, that most of the energy store, the fat, is going to go right to the liver. So they did studies on just giving people 2 cans of soda a day for 6 weeks. They only gained something like 4 pounds of fat, but the majority of the fat was right in the liver. Meaning, guys, if you want to have a fatty liver, if you want to increase visceral fat, make sure you eat a lot of sugar. Make sure you consume a lot of sugar. If you want to avoid all that, and if you want to improve your whole system, including your immune system, it's your immune system that I'm really trying to get you to understand here. Okay, if you have a sick body, how the hell do you have a strong immune system? Remember, your body's like a triage, man. It's checking in on everything. And if the body's constantly going, man, I got to pay attention to this and that and the other thing because this is all messed up, it's not good. Because when a pathogen comes into your body now, your body's already worn down from stress and from all this shit. You get what I'm saying? So let's fix it. So lower sugar, higher fiber, more fermented foods, mix of plant, fish, animal, and organ meats. For your fats, you're going to get nuts, you're going to get seeds, you're going to get certain oils. Okay? What oil do I love? Extra virgin olive oil, guys. That's the oil that I'm telling you also helps to dampen that insulin response. Okay, we want to keep insulin in check. We want it to do its job. We don't want it to keep spiking. We want the signal to be respected at the cellular level. Allow it to do its job, escorting these the glucose and the various electrolytes in and out of the cells as your body deems necessary. Okay? Are we starting to get the picture, guys? All right? We need a healthy body in order to fight pathogens. If the body is caught up in this whole entire energy spillover, things get sick. Organs get sick. They can't do their job. What the heck do you think your immune system is? All hands on deck. That's what it is. All hands on deck. Well, all arms on deck for that matter. All right, let's go. Let's go. All right, you like this information? Give me the thumbs up. Give me a comment at the bottom. Share with your friends. And if you haven't already, please subscribe. Thank you, guys.